Welcome to the first video course episode about REST as in Hypermedia together with Java. So in this episode I will talk about different levels of HTTP APIs, what the strengths and weaknesses are, and when to apply which. So you know how to insult a developer? You just tell them, hey, your API is not RESTful. And even though you may be right, it's of course first of all a question whether it's necessary to be RESTful and buzzword compatible. So of course we always should ask ourselves the question when it makes sense to apply a specific technology or a specific approach. And other than just being compatible with REST or not, I want to show you what it actually means and what the strengths and weaknesses are of different levels of approaches which you can apply. So there's a so-called Richardson maturity model, which shows different levels of HTTP. In general, REST is not really coupled to HTTP only, but rather than focusing too much on the academic approach, I want to show you the relation to the real-world projects and when to apply which. So I highly advise you to read the dissertation of Roy T. Fielding about REST, but this is another story. So for now, there are several levels of this REST APIs or HTTP APIs and when it makes sense to do which. And I want to show you these by examples. So let's talk about coffee, because everybody loves coffee, right? And we're not talking about Starbucks and some nice and fancy coffee cafes, excuse me, rather than good coffee shops. So if you go into a good coffee shop, you are thinking about what kind of drink you want. Maybe you want a freshly poured espresso or a pour-over coffee or a latte macchiato or something like this. And you're thinking about the drink. And then in good coffee shops, you can also choose bean types, right? So for example, they have beans origins from Colombia, from El Salvador, and so on and so forth. And some of them may fit better to a specific kind of drink and some of them don't. So you're thinking about a kind of drink first, and then you maybe ask for recommendations for beans and so on and so forth. And then you order the coffee and you wait for it, and at the end you fetch the coffee, right? So even if this is a very simple and basic example, it's yet sufficient to show some kind of constraints in the logic and the basic workflow in the API. Imagine you have a client now and the server communicating this, and you want to think about an appropriate level of HTTP API. So let's start with a basic example. This should be an HTTP documentation on a really low level, showing you HTTP requests and responses, how they look like, and you get a feeling how the HTTP could look like. And I'll tell you what the strengths and weaknesses are of these approaches. So the first approach is a very simple use of HTTP, just straightforward. You can define whatever you like, basically. And this is a so-called RPC style approach of HTTP. You're basically defining methods and you call them over the wire. And of course you may say, wow, this is not good because it's not RESTful and this doesn't comply with a lot of things. But hold on. If you're building one server and one client and they are tightly coupled, you're basically free to choose whatever is productive for you and to choose whatever makes sense. So let's look through the examples to get an understanding of the workflow. First of all, you ask which kind of coffee types there are. If you want to have an espresso, a pour-over, French press, or a latte, for example, and it shows you which one are available. For example, one of the machines may be broken, so today unfortunately there's no pour-over and stuff like this. So you want to get the types first. And you call get coffee types, of course with post, because everything is post, right? Actually, it's not bad to take post in this case. It's better than calling methods via get if the methods may change state on the server. So later we see that if you call other methods down there in these examples, it wouldn't make sense to take get, because then it can be kind of dangerous. So we're posting something to a method. It may be a request body type or just calling the method with method parameters, with query parameters, and then you get a response. It's very simple. And after you get the coffee types, you can choose a bean origin. And you ask for the available bean origins for your selected coffee type by calling the method getBeansOrigins, and you also get an array with JSON data back. And in this case, it doesn't matter if you use XML or JSON, it's just showing you the concept. So there's no difference if you would take XML and wrap it into a request and response object, what you typically see in these kind of APIs, but the approach is the same. And after you get the bean origins, you can select them as well. And then you finally order your coffee with a specific coffee type and a specific bean type. In order to do so, you're posting to another method called orderCoffee. And as I said, either in the request body or in the query parameters, you give your selected types and origins, and then they say, okay, I just got your order, and here's your whatever order ID, for example. This is tightly coupled to the logic as well, as you can see. And then you have to wait as a customer as your coffee is being prepared. And then eventually you can either you get notified on the client, it depends on the architecture, but typically you can poll for the status and ask for your drink if it's finished already. And you do this by calling getOrderStatus in this case with the ID you just got back from the last response. And then you get a status. It could be plain text or any kind of format. For example, it says finished or still preparing. And as soon as it's finished, you can fetch your selected, your finished drink by calling the method fetchCoffee. Of course, again with post, again with 200 OK status code, you give him the ID as a query parameter, and you get back finally your espresso from Colombia beans. And then you can enjoy your drink. So you saw a few things here, which maybe not as perfect when you call an HTTP API REST. But again, as I said, if you have just one client and one server that are tightly coupled and you're free to choose whatever you like, then this kind of approach is totally fine. But please don't call it REST then. It's totally fine to call it HTTP API, period. And as you see, of course it has some strengths because it's simple and it's productive. You define some kind of methods which may be reflected as your business methods in your enterprise application as well. You just call them and then you're free to go, and you're calling all the transactions on the enterprise side. And this is very simple and very lean, of course. But it also has some weaknesses, or it has some risks, because if you want to evolve that API or change stuff later, then you're really tightly coupled and you have to change both the client and the server, ideally at the same or possibly at the same time. And if this is no problem, or if this not not a constraint on your side, then this is fine. For example, if you have a small team and one team is both in charge of the client and the server, then this is a good approach or a doable approach. But let's look one example further. Now we want to introduce two things: resources and semantic HTTP. Because in HTTP in general, everything you're talking about is a resource, so an identifiable object, and these resources should in fact reflect your domain entities in your application. So you're talking about coffees, you're talking about bean origins and coffee types and orders and so on and so forth, rather than talking about some kind of methods you're calling. So strictly speaking, this is a more appropriate approach for using HTTP. and you're using Semantic HTTP, so HTTP verbs as how they are meant to be used. For example, let's do the same workflow again. You want to ask for coffee types, so you get the coffee types, get in this case because it's just a read on your side. And 200 OK, and the same response is totally fine because you get here a JSON array with all the available coffee types. And then, as the second example, you can get for the origins, for the bean origins available for that specific coffee type. So for example, there are different approaches possible here. You can model that into the URI if it makes sense. So you say types espresso, and as a sub-resource of that selected espresso, that selected drink, you can get all the available bean origins. It's totally fine. If you do so, then you get the array back as well. You could also do a query parameter, for example, or even post a new selection, but then you would have a more sophisticated and more complex approach. So I think this is a pretty good match in this case. And then, of course, you want to order the coffee again. And now you're creating a new resource. So now you're really working with resources and Semantic HTTP, which means you're posting to the orders and give the coffee, in this case, as a selection as the request body in JSON. And then you're not getting 200 OK back, rather than the server tells you that a new resource has been created with 201 created status code. And it can even direct you to that newly created resource by the HTTP location header and giving you the URL of the newly created resource. And you will see this later again. This is the first occurrence of hypermedia because you're linking to the newly created resource. But then let's move on. Now the order has been placed and you're waiting for it as a customer, and you can check the order status by just calling the order, the specific order, and this is in fact the same URI you just got back in the HTTP header. And then 200 OK, and the order as the selected type, origin, and now a status, preparing or already finished, for example. And then finally, as your drink has been finished, you can fetch it. And there are several types possible again, so it depends on your business logic. If you have some kind of customer queue where you have to wait for your coffee and one after another, then you could post to that queue and post a collection object. Or in this case, you're just saying, okay, now I got it, thanks, and you're just updating the resource either with put, like here, or you're doing a patch. This is also possible. And then you're putting to the resource and updating the status to say, thanks, I collected my coffee, thanks and bye. And the server just responds with, fine, 201, no content, you know the resource, I don't have to give it back to you. And then you're done and you can enjoy your coffee. This is how this approach works. Again, some strengths here and weaknesses. So the strengths obviously are that you have REST has one constraint called uniform interface. And here you're getting closer to the uniform interface approach, at least on the URLs, on the resources level, because now you say everything that is a business domain entity can possibly or probably be get and post and put. So if you read the documentation here and read get types, then at least as a developer, you already know or assume what this may do. Rather than if you just have a method name, unless you know the method, you have no idea what happens on the server side, right? And this is how this approach can be used. And the weaknesses are, it's maybe a little bit more cumbersome to talk about resources and updating resource status rather than just calling a method. So for example, if you have a customer waiting queue, then you would have to post to that queue and get that status and update it later rather than just calling a method like fetch coffee. So it depends on your implementation and it depends on your business project process. But ideally, you model the process as close to your resources. which means if you have a kind of queue, then you can post to it, for example. And this is the second approach I want to show you, introducing resources and semantic HTTP. And this is actually how REST is mostly used in real-world projects, right? You say, okay, we have resources, we name them as names and nouns rather than verbs, the URLs, and we use some kind of semantic HTTP approach. Technically or academically speaking, this is not really REST yet. It has some REST constraints here, but not all of them. And as I said, REST not necessarily has something to do with HTTP, but just talk about HTTP APIs here, and this is a nice approach of doing so, and most of the rework projects do. Again, you would have to know a few things as a client to call this. So this approach is appropriate for having more clients and not just that tightly coupling on one client and one server. But obviously you have to document what you're doing here, because unless you can assume a couple of things as a developer, as a human, still you would have to know which resources do what, like what are types, what are espresso origins, for example. And of course you would have to know what to post, for example, to get an order, or where to find these resources, or how the request body looks like, and stuff like this. And in order to do so, typically you have either a document, like Word document, or an PDF HTML document showing you something like this, what I'm showing you here, how to use the resources, what kind of types and objects are there, and so on and so forth. There's also another format available called Swagger. This is highly used in real-world projects because it's a productive way of documenting these APIs. You can either write a Swagger JSON or YAML file, and then having this nice and fancy HTML documentation generated, or there are even tools around to generate that documentation out of your code, and then you can use it and browse through it, look at all of the resources available, look at the request bodies you have to post, and oh, you get these status back and what can happen here, and so on and so forth. And you can even try it out as a client. So as developers, this is a really productive approach of doing so. And this is the reason why it's quite common. So again, this is a nice and usable approach. But let's move on. What else is there? Sorry. REST is about hypermedia. And in hypermedia, you're linking resources which are somewhat related to other resources together via meta information. And typically you're having links and then other form of controls. So let's introduce some links first. And if you think about a website, like as a human, it's the same thing. Because if you go to a website like Amazon and you have the URL in your address bar, you don't look for, well, article IDs and take the article ID, append it to a URL and build the URLs and so on and so forth, rather than you navigate via links. And you typically get to a home page and you see all the links available through a navigation, for example, and you can select one link and then your browser follows you. And the same idea is true for hypermedia, and this actually is the hypermedia idea, and you can totally implement this in an HTTP API, and it definitely makes sense. For example, if you define a so-called root resource, like get coffee shop, you get some meta information back. And there are several approaches possible. For example, you can return them in the HTTP header with a link header, or you return them directly in the response. So now, and as your resources are in fact, strictly speaking, not really your domain entities, but only a representation of your domain entities. And the difference is then that you can wrap it around or enhance it with meta information, like these links here. This can be used to direct the client then. So you have some links telling, for example, oh, I have some types here, and you can find them under this URL. And this markup here is just defined by myself. This is actually just pseudo content type for hypermedia. There are several approaches out there, but it should just give you the idea how to do this. So this types is a relation. It's just a string, and the string obviously has to be known. So it's like the link name in your browser, showing you contact information on that website, for example. And you know as a human, oh, contact, this is what I'm searching for, and you click on it. And it's the same idea. It's directing you to types and orders later on. So as a client, you can follow, oh, types, fine. I follow this resource with a get, and then I go to this. So now I can get the coffee types, our example again. For example, espresso, pour over, and so on and so forth. And these are linked to the origins then, because the origins are coupled to the coffee type. And then rather than assuming how the URLs look like with espresso/origins, you now are directed as a client directly to that resource. And the same is true for all of them. And then obviously as a client you don't have to know that much how the URLs are created. You just have to know about the business logic and the names so far. Let's move on. You can get the espresso origins here, and again you get, for example, that JSON array back, and then you have all the information you need to order a coffee. And as you saw in the beginning, you also link to the orders resource, so you know where to place orders. And you do so in the same way by posting your type and your origin to that resource. And then again, you get the 201 created back with the location HTTP header, which directs you to that specific order. And then, oh yeah, you can also get that resource and get a list of all the orders. And that list, for example, may include only a subset of the properties of each and every order. For example, you don't see the types and the origins here because it may be too cumbersome to show all of the 100 orders at once. But just showing the most important information, like a name or the status here, saying, oh, this one is finished, and you can access it under that URL. And in order to do so, and of course you also got the URL back in the beginning, you can just get the specific order and just as before, you see the status again, and you can update it assuming you're doing a put again. So what are the strengths and weaknesses of this approach, introducing hypermedia for your API? First of all, the server is now in control of the URLs again. So you could even change the URLs here. But you may ask yourself the question, oh, why should I change the URLs? I mean, who cares? They never change and that's fine. But you can also use this approach to include some business logic. For example, here you link to that specific origins, or you link to the orders. But for example, if that order system is not available, or if for some case the client, based on the authentication, is not allowed to access some resources, you won't include that link as the resource from as the response from the server. And then the client can rely on a couple of things, saying you get the response back, and I know that URL and I know that relation, and I follow it if and only if that is included, and I don't follow it if I don't have the link, because then I don't even know the URL. So this is the approach of coupling it more loosely from the client and the server, so the client does not know how to construct the URLs. So the client does not do some URL concatenation, and the client in fact should only rely on these relations, and then they could possibly change or not, but this is a more loosely coupled approach. Of course, it gives you more flexibility and more power and control, but it's also more cumbersome, and of course not that productive than just going straight away like in the first approach. So the benefit is here, if you have a larger set of client and more variety of clients, and your project lives longer, so you may possibly evolve over time, and your API may evolve. You can also use this for a more dynamic approach, saying, oh, you have the version 2 of our coffee shop, and by the way, it's linked here. And all of the old clients still work because they still rely on their old links, but the new clients can rely on the new stuff. And you can use this to evolve further, and so on and so forth. Of course, you shouldn't use versions, but just evolvability on the client side, but that's another talk. But you see, you can use these links dynamically. But of course, the weaknesses are it's not that productive as just tightly coupling the clients together. But you now hopefully got the idea what these links provide you. It's actually the same idea like on a website as a human. You're being directed through the links available, and you can do certain kind of stuff. So in Amazon, if you're not logged in, you probably can, of course you can, but you can't order an article directly via the add to shopping cart button, or place the order and check out if you're not logged in. So your button is maybe not displayed or redirected to somewhere else, and the same is true here. And now another approach, introducing controls. Because in the last approach, you probably ask yourself the question, oh, it's nice that I know where to find this resource, but how to use it, how to place an order, and what to post to that order. Because when you're being directed there, it's nice, but I still need to know, how to use this resource. And in order to do so, you can introduce controls. And again, to show you the idea, it's basically the same idea of a website using forms. You give your client a form, for example, for some contact information, please contact us, and type in your question and so on and so forth. And even if your client doesn't know your website and has never been there, they could possibly fill it out because they know what they're being asked for, like a name, a question. And as a humans, they know what you're talking about. And by using the form in the browser, you're just telling, oh, please post that form to this URL, and here are the fields, please fill them out, and then you're ready to go. And the same is true here. And in order to do so, this is another approach I just introduced, however your content type might look like, but from the idea, you can use some kind of actions, some kind of controls, which are not just links available via GET, rather than being able to post or put. So you have an order coffee action here, which tells you, oh, over that URL, you still know it from before, but now I tell you what to do here. You have to post to that URL, and by the way, I want to have two fields, namely type and origin. And now you tell the client how to use that resource. And obviously, the client has to know what these names are about. So it has to know what a type and an origin is, in fact. And of course, it has to know what order coffee is in this case. And then you can direct the client further. So for the sake of the example, let's go through. We get our coffee types, fine, just as before with the Hypermedia example. You have the links to the subsequent resource showing all the available coffee beans. So you get all the idea what you can do with an espresso in our coffee shop. You can order coffee from Colombia, El Salvador, and so on and so forth. And oh, by the way, so now it depends where you want to include that information of the action, but you can actually already include it here if your use content type, for example, supports something like I fill out the value for you. So if you're on this resource, espresso from Colombia, then you already know what you want to order. And then I can tell you, oh, here are the available options. It's like a link on the website, order here, because you already know the origin and the coffee type. So you can direct the client directly here. to post to that URL with the data available. And the same is true for the other types. And then your client is directed. And then again, you have to post, but now you knew upfront what you were doing. And then you can get all the orders, just as before. And then you can check for the order status. And again, because you should do some action, you can direct the client how to use it. For example, collect their coffee by putting, or you could also do a patch, for example, to that resource by saying, these are the values I suppose, and there's only one possibility here, so you should post your finish, status, and maybe the others as well to that resource. And then you do so, just as before, but now you have been directed. So what are the strengths and weaknesses of this approach? Obviously, a weakness is it's quite cumbersome because it's a lot of stuff to do. You see, this documentation is already much longer than the others. But what do you get? You get even more evolvability because possibly you can change anything on the server side and just tell the client how to use this. But again, with the relation to Ariba projects, I mean, why should I change post to something else, right? No, but the idea is rather than changing the low-level stuff, you could change, for example, the whole action, saying, oh, now the order coffee for some reason is not available, so I don't include it. And the client gets more stupid in terms of business logic, but also more dynamic. So the client only relies on order coffee action. I know I can order a coffee somewhere and I just have to look for that action. And if it's not included, then I'm not available and not able to do so. So I only include my client logic, my links, my form to order their coffee if and only if that action is given, for example. And then you're more flexible on the server side. For example, if you want to change something over time, you're introducing new actions and you evolve your API, you don't break the client, and you can even adapt the client later on. This is obviously a strength. And then again, the greater your number of clients is, and the greater the variety of clients is, then the more it makes sense to introduce some kind of approach. For example, if you are a big website like a Twitter API or GitHub, actually GitHub is introducing some hypermedia or has been introducing that, and it's now usable from the REST API, then it makes sense to direct the clients, because then the client can really program a more dynamic approach and adapt to your changes as well. So this totally makes sense if you have a great number of clients, and that should be used more commercially and in a longer time span. So this is a totally opposite approach, for example, from the first one, where you're really tightly coupled. But I hope you get the idea, and I hope you get the understanding when it makes sense to use which. So again, please don't use REST, or this is true for any kind of technology, please don't use it just for the sake of the name or for the sake of the technology, but just be aware of all the possibilities you have and when to apply which. And to carry on, because I showed you some things about hypermedia, there's a so-called H factor from Mike Edmondson showing you the different levels of hypermedia. Like the third and the fourth example, what I showed you, maybe you're only using links or you're using hypermedia controls. And you see, for example, if you think of HTML, then you know that for HTML forms, the example I gave you, it's not possible to do a put or a delete, for example. You can only post or get. And obviously, this is a shortcoming of that content type, but here you're really talking about content types rather than the concepts I just showed you. So there are several so-called hypermedia-enabled content types, like HEL, like Siren, like JSONLD, JSON collections, Hydra, and so on and so forth, available, and all have their strengths and weaknesses. More and more complex and powerful. Others are simpler but more productive to use. So the same story is true within using Hypermedia. And you just have to look at them and choose when it makes sense. So don't just use the best academic approach of now we are really RESTful using Hypermedia controls, but think of whether it makes sense or not. And actually there's even a level further, because for the last approach you saw, oh, actually I don't have to document a lot here. So I actually don't need Swagger because some kind of Swagger is already included in my API, or at least usable in my API if I just go to that single resource and then explore the API and what is possible by following links and following actions. So obviously a big strength is that you don't need to document how to use the API, how to use the actions, how to use the resources, what to put, post, delete, and so on and so forth, which content types to use and which information. The only thing you need to document in this approach is the action's name. So the client has to know what order coffee is. I mean, this is obvious because the client at some point has to know what to do. And then the field names, because still you say, please provide me the type and the origin. And as a client, you have to know what a type and an origin is and where that information comes from, if it comes from a form and so on and so forth. And there's even another approach, having more information as meta information in your API. And this is a schema approach, for example, via schema.org. If you look at schema.org, this is an approach to standardize domain entities. For example, you have things like organization, businesses, coffee even. You have a coffee shop there, so there's a standardized schema for coffee shop. And why do we need this? For big organizations, you have the same things all over again. You're always talking about organization, you're talking about customers, addresses, names, and so on and so forth, and all of them have their own schema. But here there is really a standard or an approach to standardize this using the typical information you may see in a real world. So for example, a typical cafe or coffee shop, what is that and what does it have? It has some opening hours, it has a price range, or it has an address because it's an organization, and this is an hierarchical model for doing so. Actually, why do we need all this? There's a content type called JSONLD. It's an Hypermedia content type as well, and it gives you the possibility to link to these schemas. So now, for example, we have a person, John Doe. The person has a name, a job title, and so on and so forth, and even an address. And now we can link via the context schema.org to what that John Doe actually is. So the computer can understand what you're talking about, rather than just having some kind of JSON with some keys, which is just possibly human readable, like a name, and you as a human know what a name is, but the computer doesn't. But now you really can tell this JSON object is a person, and you can find the person there at schema.org, and you link really to that entity, and it's explaining what a person is. And then you can also include really a documentation of your domain entities, so the client, even the machine, can understand what you're talking about and what you need in that case. So this is an even further approach of doing so. Now you may ask yourself the question, whoa, when do I need this? So you can need this to provide some meta information from your resources. For example, Google is now possible and able to scan websites and scan resources for that information. For example, if you write an email to your client, oh, congratulations, your flight to San Francisco has been booked, and you include the flight data as meta information, for example, using JSONLD, and actually Gmail is capable of understanding JSONLD, and then you can provide some meta information about that flight. And now Gmail is able to understand what your email is saying, because it got the email and saying, oh, I have some meta information. It's about a flight, and the flight is departing from here and arriving there at that time. And by the way, do you want a calendar entry for your flight? Because I know the times here, because I kind of read your email through that meta information. Obviously, you have to include that meta information up front, but this is really a standardized approach of understanding business logic. And that's a really nice approach. But I highly doubt you will need that for real-world enterprise projects, but this is just to mention that concept type, and just to mention that some approaches even possible more on top. So maybe you look into this schema. It's a really nice approach here. So that's it for the coffee shop. I hope you got an example from different levels of HTTP, and especially what hypermedia is usable for and when to apply it and when it really makes sense to do so. So thanks for watching the first episode of this video course. Talking about especially RESTful web services. I'm from time to time offering workshops and trainings about all kind of topics. So especially about REST and how to implement HTTP APIs and how to do the architecture of this, you can contact me. So thanks for watching this first episode, and the next episode is now really hands down how to implement HTTP and REST on the server side using Java and Java EE technology. Thanks for watching.